All right, so today we're going to spend some time talking about um, ways of getting data external from our application, in this case, our video game, into our game, and what's the right tool for the job. So let's draw a picture here, and I've already written up some code that we can walk through and see some options for this. So let me go here. All right, so here's our game. Game lives down here, and we have a whole bunch of things that live inside of that game that are very much local types of things. So um, we have our scenes, controller logic. Should say game objects, and then I'll just do a dot 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 after that. So a whole bunch of stuff that really lives locally in our game. Now, something we've introduced in our last class, or started to introduce, is the idea of having items. All right, so I think in our current rendition, the items we have are um, I think we just have a cherry at this point, but we kind of talked about maybe there's a sword that adds something to your attack and things like that. So um, the question is how do we get the information about our items? So certainly we can go in and we can just hard code stuff inside of either our singletons or whatever, but at some point, you decide that, look, this doesn't have to exist inside of a kind of a programming interface. Instead, we want to have um, our items listed inside of maybe a file or a database or something like that. So we want to talk about what the different options are for that. So for example, go yellow. You can have a file. I'm going to go ahead and I'm going to just create a slide here. And files are actually kind of interesting in that, a long, long, long time ago, the only way to store something persistently between runs of your application was in a file. That was something that like lived even when your game stopped running, and the next time you loaded your game, you could read the stuff back in from a file. So this is local only. We can say relatively slow, and what that really means is file IO is slow. And that's kind of related to, at some point we've seen, um, uh, I think I showed a for loop at some point where we did something a million times or something like that. And if we were just counting, it ran really, really quickly. But if we were printing out each time, it slowed way, way down. So in general, we can really say that IO is slow in general. And file IO, we could say file IO is extra slow because we are reading the file from the hard drive. And more modernly, it wouldn't be a mechanical hard drive, it would be some kind of solid state drive. So solid state drives, while much, 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 much faster than a traditional mechanical hard drive, are still very, very slow. So SSDs are very slow relative to system memory, which is slow compared to, say, cache memory. like L2, L3 cache. These are things you might be talking about in your 325 class, the computer organization, and much slower than hardware register memory. Punchline being the closer you get to the actual CPU, the slower or the faster the memory is. So since physically on your computer, sitting there locally on your computer, file IO is living on the hard drive. The hard drive is basically our slowest memory on our computer. Maybe you can, if you start measuring against like a USB stick or something like that, you might run into a situation where it's even slower. But as a general rule, files are local only. All right. Now, what's another option? Another option is a database. So databases can live locally or in the cloud. So local databases are abstractions that live on top of a file system and allow us to do things like query the database for information. Typically, queries are typically done using SQL or similar. All right, so SQL is a query language that allows you to just ask the database, like, give me the user ID of the user whose first name is Mike and last name is Littman, something like that. But these would be abstractions of a file, especially if they're living locally. But even if they're living in the cloud, that just means they're not sitting locally on our computer. They're instead local on some other computer, and we access that data over the internet. That could be handy if we have a multi-user application or something like that, where there is shared data among multiple people. So we could do something like this. When should a DB be local? We could say when the data is only for the locally running application. When should a DB be in the cloud? When the data is shared among multiple users of an application. You can think of this as similar to a singleton. So when we put data or database or whatever, when we put something that's accessible, when we put it in the cloud, what we're effectively saying is this is now available to multiple people, not just people sitting on my computer or sitting on my local network inside my house, that kind of stuff. All right. When should you use a database at all? We would say when data needs to be stored in a structured way, and we want to query that data in various ways. Now, databases do come in a whole bunch of different flavors. We have kind of your old school databases. I think most of you have probably not had the database class yet, CSC430 or whatever the new 4-digit number is going to end up being. I'll have to memorize those at some point. But that class kind of gets into the different types of databases and things like that. But historically, our older databases might be relational databases where their goal was to minimize the amount of data that needed to be stored. So one of the goals would be don't duplicate the data too much. If you're going to have a user ID stored somewhere, don't store it in 20 places, store it in one place, and then through querying, be able to incorporate it into other tables and things like that. The the rationale behind that, and this may be something, well, it's something we've talked about in here, but with like the Y2K bug in the 200 class, when we said, why did they use 2-digit years instead of 4-digit years? Well, it's because memory used to be really scarce and really expensive. So we had to be careful of not using too much memory. We wanted to use the smallest footprint possible. Now, so that was kind of the mentality for relational databases, and that's something you'll talk about in much more depth in the 430 class. More recently, we have a different type of database. Usually these are more object-oriented databases, and data might be duplicated many, many, many times because when you access the data, you're going to access it over the internet, and you will access it from a data source that is regionally close to you. So your access is quicker or something like that. So we don't pay as much attention about duplicating data. We care more about the performance of the data. All right. Now, that isn't to say, so if we say database rules of thumb, we have cloud storage. This would be through something like Google Firebase or Microsoft Azure or Amazon Web Services, which has several different ways of storing information. Local databases, or I'll say local network databases. Actually, let me separate those two. Local network databases. So for instance, maybe a big company like Northwestern Mutual or something like that, that has very sensitive data that they might not want to have easily accessible over the internet. The only way you can get to the data is if you're on their local area network at the office or whatever. These would be enterprise databases like Oracle, Microsoft SQL Server. DB2 is another big one. That's an IBM product. IBM DB2. Okay, so these would be expensive, capable of handling, lots and lots and lots of simultaneous queries, things like that, but is not necessarily accessible from the cloud. It could be accessible from the cloud, but isn't necessarily. And all of these are those relational databases. Now, local database. So these would be mostly free. Probably the easiest one is something called SQLite. We also have things like MySQL, PostgreSQL, ... So these are all mostly freely available databases. They're all relational databases. You install them on your local computer. SQL is actually, it doesn't even do anything special. It's basically a query language overlay on top of a normal file IO. So we would call SQLite appropriate for like a single user application or 2 or 3 users who might be accessing that database at the same time, whereas MySQL and PostgreSQL are much more appropriate for even smaller enterprise type applications. Only when you get into the big must handle zillions of hits per second, like maybe the authentication server on Amazon. When you are logging into Amazon, that could be a lot of people at once might be doing that. And each one of those authentication requests are hitting their database. So they need something that can handle millions of hits per second, where that's not MySQL or PostgreSQL. That guy can hit like 100 hits a second or something like that. And SQLite, it would be more like 5 hits per second. So much, much, much smaller. All right. So these are your kind of different uh, types of databases that exist. Again, our conversation here is less about the details of these databases and more of what's the right tool for the job. So let's add a slide for this. What is the right data storage for different situations? So let's just think about our items for a second. So let's say, let's use our game items as an example. So as of right now, the way we've written our game is it's a single player game. Runs on a single computer. We don't have to have that data available to multiple people over the internet or anything like that. So the idea here would be that if we're only going to store our items locally, and so if we are only going to store the items locally, and we are not needing to do powerful queries on the data. So like in our case here, we kind of have a list of items. So maybe we have an item called a cherry that impacts hit points, adds 5 hit points, something like that, I think is what we did. Maybe you have a sword that impacts like attack or damage, however we want to think about it. And maybe it adds 3 extra damage if you're wielding a sword while you attack, that kind of stuff. So effectively, we have this list of items that impact different things. Now, realistically, when our game launches, we're not really querying those items for extra information. We're basically saying, I want to take from that file, I want to read in all of our current items. So maybe there's, well, right now I just described we have 2 items. 2 items that exist in our game, a sword and and the cherry for healing your hit points. Well, when we first start our game, we want that data to get read into our game. And when the game is stopped, we want to be able to update those text files in such a way that it's not programming, it's just text, and put it in a certain format. We'll look at that today. All right, so we might want to store our item data inside of a normal file so that we can read the contents of that file in during runtime. Then we might ask the question, do we need to format the data within the file? And that's kind of what we're going to look at today. All right, so let me start off. I've already prepared a couple of things here. We're going to start with this guy. All right, so I've created a little text file called items_data.txt. And I used a program called TextEdit on my Mac to do this. The first thing you would do if you hit new, you would go in here and you can use any text editor that you want, but something to pay attention to, and I think like Notepad on Windows does the same thing. By default, this is probably a file in rich text format, which isn't the end of the world, but we're just storing data. We don't care if this file looks pretty. This file's one and only purpose is to just store information between runs of our program so that we don't have to kind of put this information inside of a singleton or something where it's just data, but we have to write it in kind of a syntactic way because we're using a C# file to store it. So the very first thing you would do, at least on TextEdit, is you can go to Format and say Make Plain Text. I think for Notepad, it's when you go and save it. You want to save it as a plain text file as opposed to is it an RTF, maybe rich text file might be the default. But whatever it is, we want to save the file as a plain Jane .txt file. What is a little weird with Unity, I think this is something that used to exist, but at the very least, I couldn't find a convenient way of doing it. If I go into Unity here, and I go to my project, well, here, I'll just go into those files that are there. I put it in a folder called data files. Now, if I right click here and I want to create something new, we can create C# scripts, we can create all these other things. We do have this thing called text, but these are like specially formatted text files for like maintaining stuff about fonts or information about sprites for 2D games, things like that. I don't see anything in here for a plain text file. It definitely used to exist, and it might even still exist somewhere in here. But in any case, I couldn't necessarily find it. Doesn't necessarily matter. What I did is I just came out here. I created my file. So notice what I'm doing here. I'm basically saying I'm going to have one item per line. And so these would be kind of comma separated values. So this is the name of the item, followed by a comma, followed by the modifier, the attribute that it impacts, followed by the modifier. So the cherry gives you, it modifies your hit points by 5, increases your hit points by 5. Similarly, I have a sword that modifies your attack by 3. All right. Now, as a human being, when I wrote this, I have to know that that's what those 3 things have in them. Similarly, I also can't have a comma in the middle of my name because now I've broken the way we're going to be parsing this. So by having a comma separated values, you basically have said, I'm not going to allow commas to be inside of my my values. Now, if it would make sense for you to have commas inside of your values, you could just reimagine, instead of using commas as your separator, maybe you pick something that's like very unlikely to be inside of your values. So maybe we say we're going to separate these pieces by a less than, double equal sign, greater than, something like that. All right. But really what we're doing right here is we're kind of rolling back in time to the very early days of programming, where we wanted to store data inside of our files in a format that we can then read in and do something with them. All right, so I'll go ahead and put that guy back. Now, after I saved our file, I saved it to my downloads folder here. I then just drug it in to my assets data files. Okay, now when we go and write the code to read from this thing, one piece of information you're going to need is if you go and right click on this guy and you say copy path, this will give you the full path to that that piece of information. So notice here it's in assets/data files/items data. Well, actually, that's my JSON file. That's what we're going to talk about second today. Okay, but my normal text file that we just created is this guy. So it lives in our folder called assets, inside of another folder called data files, inside of a file called items_data.txt. All right, so that's the way I brought that asset into my project rather than adding it inside the project. If you figure out a way to create a blank text file in your project, let me know. I looked at it for like 5 minutes, couldn't find an obvious way of doing it, so I just created my asset externally. This is basically the same thing we did for the first couple stupid audio samples that we had, where I downloaded it off the internet, then we drug it into our assets folder. So all kind of the same stuff. But in any case, I now have some text files, and we're working with this first one here, which is called items_data.txt. All right, and this guy just looks like this. All right, so what I'm going to do now is we're going to say, you know what, when our scene here loads, even though I'm not incorporating the data into our scene yet, when our shop scene loads, we want to go ahead and read in the available items from our item text file. All right. This being, with the idea being that we can add or remove things from our text file during runtime. All right, so I'm gonna go ahead into our controller for our, is it shop controller? We'll go into our shop controller here. All right, now one thing we're gonna need for reading in files is something called system.io. Okay, and at this point, I'm doing this as a mono behavior. So our shop controller is attached to that empty game object. And this guy kind of oversees the stuff that's happening inside of our shop. All right, so we're only looking at this. Actually, we're not looking at that. We're only looking at this right now. This is our second way of doing it that I'll show you here in a few minutes. So here's us just reading in a plain text file. So I wrote a function here called read items data. You could have called this LOL. You can name the function whatever you want. I'm not returning anything, but this is just doing standard file IO. So this is file IO is kind of something that is still important in computer programming, but often gets overlooked nowadays, since everything is kind of done in the cloud or through API calls or things like this, where sometimes the simplest solution is the oldest solution. All right, files still exist, and if you have a whole bunch of stuff that's just being used locally on your computer and it doesn't need to be super turbo fast, throw it in a file, because that requires the least amount of overhead. And by overhead, I mean even just setup. So if you were going to use a budget pleaser database like MySQL, which is a free database, you still need to go and download MySQL. You need to configure it on your computer. You got to set it up as a listener. You have to write the Unity code that talks to your locally. It's basically talking to a different application that's running on your computer. So at that point, you have Unity running and you also have MySQL running. And now you're making calls to the local MySQL server to retrieve data and things like that. And also adding data into a MySQL database is not super convenient either. There are web-based user interfaces where you can just create a table and put stuff in one by one. It's not overly difficult, it's just kind of a web form for adding pieces of information. So maybe you would have 3 little text boxes, one for the name of the item, one for the attribute, and one for the modifier. But it's still using a whole separate application to store what we would probably say is fairly simple data here. All right. And this data doesn't need to be super turbo fast. Effectively, when the scene first loads or your game first loads, we're going to be reading in the files from the data. So if our game takes an extra 2 seconds to originally launch, yet you kept all this stuff self-contained in the game through local files, who cares? It's not that big of a deal for that. So in this case, we don't need this stuff to be to deal with thousands and thousands of hits per second or anything like that. So we just stored it as a local file. We brought it into our assets. I copied the asset path. So I showed you how to do that here. So once you drag it in here, if you need to get the path to that file, you can either just look at it here or just right click on your file and say copy path. And that will give you this string right here. All right, so my file lives here. Assets, / data files, / items data.txt. All right, now what I'm going to do inside of this read data items is I'm going to be building up this string here. And I kind of do that for a different reason. So for right now, ignore the answer part of this, because I show you 3 different ways of doing this today. We're going to look at a plain text file, which is what we're dealing with now. Then we're also going to look at a JSON file, both using what's called serializable JSON, as well as just manually parsing JSON. And you'll see those through examples. All right, but we're going to call this kind of the easiest approach here, That is, I'm just reading from a plain Jane text file. Each line of this text file looks like this. I want to split it up on commas so I can get 3 individual pieces, cherry, HP, and 5. And I'm going to use those 3 pieces of information to represent, stuff about my items. All right, so this is the file path. As long as the file exists, this stuff lives inside of system.io. So whenever you're doing file stuff in C#, it lives inside of system.io. If you're doing this in Java, it's java.io is the stuff where file IO lives. So every language is going to have facilities for reading and writing files. All right, so as long as that file actually exists, and we know it does because we copied this entire path, so we probably could have left out some of this error checking, but this is good programming practice, let's say. We're going to, so if it exists, we're going to try to do something, because one thing that can happen is something can go wrong while you're reading a file. So for instance, if you're trying to read a file from your program, and your program doesn't have the necessary permissions to read the file, so maybe it's only owned by the system administrator, and your program is running as the local user, they might not have access to even read stuff from that file. All right, but again, for us, we pretty much know that this is all going to work just fine. I lost my mouse. Where'd it go? There we go. All right, so that's what this try catch thing is. So we try to do a bunch of stuff here. We catch an exception that might occur. We had looked at something along the lines of this when we looked at Java. Most of our modern languages have something called exception handling that allows our program to either recover from errors or crash more gracefully, that kind of stuff. All right, so really this try catch structure just says we're going to try to do all of this stuff, and if something bad happens, catch that error and let me deal with it however I want to deal with it. So all I'm doing is printing out that something bad happened, and then I'm going to print out what the message was of the thing, a bad thing that happened. I think we know that this isn't going to be a problem in this case, since we know we're working with a file that really exists, with a path that really exists. Although maybe if we try to parse it on commas and we forgot to put a comma here between like HP and 5 or something like that, then it's going to scream at us. That kind of stuff might cause error, and then we'd be able to handle that through the exception. But we're going to make the assumption that we write our stupid little file reasonably. All right. So first thing we're going to do is we're going to create this thing called a stream reader. This is just a C# class for reading in anything that's a stream. So this can read in from the keyboard. This can read in from an internet socket. In this case, we're reading it in from a file. All right, so there's lots of ways to read in to construct the stream reader. And remember, when we have more than one function or constructor with the same name but a different number and or type of parameter, that's called polymorphism. So there's multiple stream readers that we can create. It looks like there's 10 overloads if you can see that that information down here, 10 overloads. There's 10 different versions of this guy that you can build a stream reader. We're using the one that just takes in the path of the file. All right, so then we're going to create just a string capable of holding each line as we read it in. So we'll call that line. This guy right here is for my second version of this. And so I'm going to skip it for right now. In fact, I'll leave it in there since I want to make sure this thing compiles. All right. This guy's also for my second version. So now we have a while loop that's going to say, while line is equal to reader.readline. So this is going to continually try to read in the next line from the file until we finally hit end of file, which will read in a null value. All right. So what does this while loop say? It says, read the file one line at a time until you run out of lines. All right. So that's going to, the very first time I do that, that's going to read in this string right there. cherry, comma, HP, comma 5. The second pass through that while loop, it's going to read in that string. All right, so the first time through line is equal to cherry, comma, HP, comma 5. Then what we're going to do is we're going to take that string, we're going to split it on commas. And that's going to give me a string array where bucket 0 will be cherry, bucket 1 will be HP, bucket 2 will be 5. All right, so we've now taken that string, we split it into 3 parts. All right, this code right here is again from my second version of this, so I'm just going to skip it for right now. Well, actually, these 2 parts of that. So now what I'm going to do is after I have my 3 parts, I'm just going to write a little for loop that goes through 3 times. So it's going to go from I is 0, keep going as long as I is less than parts.length. Parts.length will be 3. 1, 2, 3. And each time through, we're going to print out that particular part. So let me show you the output of that here real quick. I'll just run this. There's several things that are in output, but I'll show you the pieces that was. So here's our reading in cherry, then HP, then 5. And then here's the second line, reading in sword, then attack, then 3. All right, so the code we just went through, that's what it does. It reads in from that file, brings it into our program, then allows us to do whatever we want with it. All right, now, something we might want to do with it is we might want to take those pieces of information and we might want to put it into like an item object. Okay, we could use them directly if we wanted. We can just, start populating our things inside of our shop with these 3 pieces of independent information we read in. You don't have to put it into an object if you don't want to. But object-oriented programming probably says you want to have your stuff organized as reasonably as possible. So I created a class here called item. Don't worry about this yet. And don't worry about this guy yet. So we have a public class item. How do I expand it? Is that there? All right. Now, usually we would have all of our fields be private. In this case, they need to be public for when I talk about this serializable thing. All right. So just let it slide for the moment. That's why we have them as public. All right. So right now I want you to just look at this class item as just a plain Jane C# class, because really it mostly is. We have 3 fields, name, the stat impacted, and the modifier. We have a constructor that takes in the name, the stat impacted, and the modifier. Now notice here that my modifier is actually an integer, like that 5 is an integer. So you'll see how I use that here in a second. All right, we just set our local variables to that. And then I wrote a little display function that will write something out to the screen. Notice this guy is not a mono behavior, so that's why we're using debug.log instead of just print. We certainly could get the, I think it's like using system or using Unity engine.system, whatever it is, to give us that print function. But debug.log does the same thing. Now, this syntax right here maybe looks familiar to some of you, or somewhat familiar to some of you from early last semester when we were working with C++. And we were using a print function either called printf, or we also had cout. Well, printf allowed us to put placeholders in. So I'm building this formatted string here where it's going to be name is equal to whatever this dot name is. Stat impacted is equal to this dot stat impacted. So this allows us to not write the string like it allows us to not have to do this. Name colon concatenated with this dot name concatenated with space stat impacted colon space concatenated with this dot stat impacted, so on and so forth. So it keeps us from having to do this big long string of concatenations, where instead what we have here is effectively syntactic sugar for exactly that. This code right here effectively does that. So this just builds up a string, displays it to the screen, to the console in our case here, with the name, the stat impacted, and the modifier that we read in. All right. So that's what an instance of item can do. It can store 3 pieces of information, and it has a single function called display that allows us to display those pieces of information. Okay, so if I go back to my controller here, we'll add in these couple of extra pieces here. So back to that exact same code as I'm reading in from the file. Notice that I'm keeping an array called item parts here that holds 3 pieces of information, because we need 3 pieces of information in order to build an item. Item needs a name, stat impacted, and a modifier. So now what I do is, inside of this for loop, what I do is I say item parts. I keep track of this variable called pause. So this is a little math trick. It's not overly difficult or anything, but so I'm saying item parts at bucket pause mod 3. So pause starts off at 0. 0 mod 3. How many times does 3 go into 0? It goes in 0 times. With remainder 0 in that case. So this will be bucket 0 the first time. It'll be bucket 1 the second time. It'll be bucket 2 the third time. Once pause becomes 3, notice I'm updating it each time. 3 mod 3. 3 goes into pause 1 time with a remainder of 0. So pause mod 3 will go back to 0. So every third value, it'll go back to 0 just by allowing me to increment it each time. I could have avoided that by just saying something like pause plus plus. If pause is greater than, actually we could say if pause is equal to 3 or something like that, then we can say pause gets reset to 0. We could have done that as well. That just makes sure that we have 0, 1, 2 from our item parts that we're filling it up, because we're going to use those here in a few minutes. Well, a little bit lower down. So after we collect the 3 pieces of information for our single item, my first version of this is just print each one at a time to the screen. But the second line of code says, let's go ahead and collect those 3 items into our item parts array. And then we're going to use that to build ourselves an item. So here's the item is a variable capable of holding an item. What are we going to put in there? We're going to put in an instance of item. So new item, and we're going to put in item parts at bucket 0, which the first time through that'll be cherry. Item parts at bucket 1, which the first time through will be HP. And then item parts at bucket 2, which the first time through will be the string representation of 5. Item parts is an array of strings. And what do I want to do to that? I want to parse the integer out of it. If you remember in Java, this function was called integer.parseInt. C#, if you have a string representation of an integer, you can convert it to the integer version of itself by passing it to the int.parseInt function. All right. So to my constructor for item, I'm passing it a string, and an int. And we see here that that's what that guy takes. He takes in a string, and an int. So we'll build our instance of item here. And then we're going to ask that item to display itself. So going back into our console here, we see here's us just printing it out one thing at a time. Cherry, HP, then 5. Keeping in mind that in that for loop, while we were doing that, we were also collecting our item parts, which we then use to build an instance of item. And here's us calling that. So I do a little print statement here saying manually parsed with item object. So here's us calling that display method of item, passing it, where it prints out name as cherry, stat impacted as HP, modifier is 5. That's this code right here. We say display it. All right, so in our first version, we're just printing out the values. We're not storing them anywhere, blah, blah, blah. But if I want to have them inside of item objects, I can go ahead and build item objects after I've collected every 3 elements and then ask that item to display itself, because working with objects is preferable. Okay, so any questions about that at the moment? So we're going to call this pretty old school type programming. Grab a drink here real quick. Just using plain Jane files, nothing special. Looks a little bit, I don't know, not overly organized, but good enough when you're only holding 3 pieces of information. Now you can imagine that as you get to more and more and more data, or your data needs to be more and more structured. So if we look at this data here, we know, since we've just been talking about this, we know that these 3 pieces of information, that this first part is the name of it, the second part is the stat, and the third part is the modifier. We've just remembered that. All right. Now you can imagine if you had 15 or 20 more pieces of information in here, things are going to get pretty sketch pretty quick. Now, comma separated value files, a lot of times what they do is they would have a very first line in here that would be something like name, stat, modifier, something like that. And then what you do is you would read in the very first line that would tell you what those pieces of information are, but you just wouldn't do anything with that first line. You would only do something with the lines after that. All right, but just for a couple of pieces of information here, not really a big deal. But we can say as this gets more complex, it might be beneficial for us to work with more organized data. So again, this is just a plain Jane text file, same kind of file as I had before, but what I put in there is the text in the format of something called JSON. And I think we've talked about JSON before, but just as a reminder here. JSON stands for JavaScript Object Notation. It is a convenient way to store information with metadata in a text file or transmit over the internet. JSON is actually pretty important because as you start getting into more and more complicated applications, or you're rating web services that are talking to a RESTful API or something on the internet, 99% of the time, those things are going to hand you the result as a JSON string. And then you'll have to parse that string out of that result. Okay. So what we're going to look at next time is how do we go about parsing this information out of this this JSON. Okay, so because I'm leaving you kind of in the middle here, I'm not going to give you homework over the weekend, but make sure that your application is caught up to where we are today, and maybe play around with the plain text files a little bit. We're ultimately going to be using the JSON here, and that's where that serializable stuff I mentioned before is going to be. So just to kind of show you right here at the end, our class here is something called serializable, and that allows us to be compatible with JSON data. So we'll talk about that in more detail on Monday. So no homework over the weekend. Make sure your project is caught up. I will push the current version of the code. It does run if you want to look ahead and see how the JSON stuff works, but I will talk about it in more detail on Monday. Questions, comments, concerns, bribes? All right, I will see everybody on Monday.